Dear students, in this session we are going to see current division current division rule. When elements are connected in parallel, then the total current that going to enter that parallel combination will be divided into the parallel paths. Let us consider a parallel combination having two resistances R1 and R2 which are connected in parallel. So as they are in parallel, one side of the nodes are connected to a common point. Let us consider that common node as A, and the other ends are connected to a common point. Let us take that common point as B. Now let us assume that this parallel combination is supplied from a DC voltage source of V volts, and the total current supplied by the source is I amperes, and as there is parallel path, the total current that going to be supplied by the voltage source V, when it comes to the point A or node A, it is divided into two paths, one through the resistance R1 and another one through the resistance R2. Let us take the current through R1 as I1, the current through R2 as I2. Now as at node A, the total current I is divided into two parts, I1 and I2. So I will be equal to I1 plus I2, and as the elements are connected in parallel, the equivalent resistance is given by Rp equal to R1 R2 divided by R1 plus R2. Now if you take the total resistance, equivalent resistance of R1 R2 parallel combination as Rp, then the total supplied voltage V equal to I into Rp, so which is equal to I into R1 R2 divided by R1 plus R2. So let it be equation 1. Now current through resistor R1 is given by, as we have denoted it I1, so I1 equal to the voltage across R1 divided by R1. Now as they are connected in parallel, the voltage across each element in a parallel branch will be equal. Therefore I1 equal to supply voltage V by resistance R1, and we have the V value as I into R1 R2 by R1 plus R2 from equation 1. So I into R1 R2 divided by R1 plus R2 into R1 is in denominator, this R1. Now from this equation R1 gets cancelled, so I1 becomes equal to I into R2 by R1 plus R2. So this is the expression for I1 current. Similarly, current through R2 equal to I2 equal to V by R2 equal to I into V is I into R1 R2 by R1 plus R2 into R2. So here R2 gets cancelled. So I2 equal to I into R1 by R1 plus R2. So this is the I2 current. Now from this we can conclude that a generalized expression we can write as the current through any branch sum Ik equal to, when two resistors are connected in parallel, the current in any one branch, suppose it is kth branch, let us assume Ik equal to total current I total into, for R1 we are having R2 in the numerator, for I2 current we are having R1 in the numerator. So I1 is the current that going to flow through the R1 branch, for that we are having R2 in the numerator, and I2 is the current that going to flow through the R2 branch, for that we are having R1. So they are opposite branch resistances. So total current into opposite resistance divided by R1 plus R2. This is total, or we can say sum of resistances in parallel connection. Okay, total current I into opposite branch resistance divided by sum of the resistance that are connected in parallel. This can be treated as a generalized formula. Okay, I1 equal to I into R2 by R1 plus R2, and I2 equal to total current I into R1 by R1 plus R2. This is current division rule. Thank you.